Hello everyone. So today we will talk about GraphQL security, and we will dive in the report we published about the topic. We also have a few surprises at the end, so stay tuned. First, we will introduce Escape. So at Escape, we are building a fully automated security platform. So the interesting point is that we are totally agentless, and so it works only with an input domain and an authentication strategy if you want to go deeper in your application. Escape is known for its unique API traversal algorithm. We will go deeper in the subject later. And we are actually capable of testing business logic and not simple fuzzing through reinforcement learning algorithm. With that algorithm, we will generate legitimate sequences of requests and exploit complex attack scenario and chain attacks such as SSRF and stuff. We're also known for our recent work about attack surface management. So you have a lot of input here, but attack surface management consists of referencing any endpoint exposed on your organization, just like Google search would index an application. At Escape, we do have a team dedicated to finding new vulnerabilities, 0 days, fingerprinting engines, on GraphQL and REST application, and continuously improving this algorithm so you can see the result here. All right, so let's get right into the report of GraphQL security topic. So we scan 1,600 API endpoints. Each of these endpoints were publicly accessible for legal reason, I guess. And so that represents a cumulative duration of 460 hours. So that's a lot of computing power at a lot of cost if you are on AWS. So we collected almost 47K security alerts, which is quite a lot. On average, this is 30 alerts per GraphQL endpoint. So this is really interesting if we do have some people in bug bounty here, because we will present you some specific GraphQL findings and some CV we reported. It happens that sometimes people tag us on HackerRank and HackerOne to say, okay, here is some kudo for the CV you published. I just got a bounty for that. So if you wish, you can already scan the QR code or take a picture of it if you want to access the complete report later on. But let's introduce ourselves. So here is Gautier. He's full stack engineer at Escape, and he is also leading the web application team. And I am Swan. I am a security software engineer. I am leading the cybersecurity and R&D part. And if you are stuck in your CTF, I am also experienced in binary exploitation.
Well, thank you, Swan, for this introduction. First, let me ask you, by raising your hands, who is familiar with GraphQL? Oh, quite a lot, actually. That's great. We'll start by introducing this technology named GraphQL and explaining why it is vulnerable by design. GraphQL is a query language built around types and fields rather than endpoints. This allows front-end developers, applications, to query exactly what they need, effectively moving from the backend for front-end paradigm. Some types may expose other types through their fields, effectively creating a graph data model. It was designed and used internally by Facebook since 2012 and was made public starting 2015, and companies started to get attracted from Fortune 500 to startups. There's another reason why GraphQL is getting popular is the graph model allows creating some kind of API gateways, effectively exposing underlying APIs built with different technologies, or GraphQL, or REST, whatever, by grouping all the data, the underlying exposes, inside a big graph with joint concerns such as authentication. Here is a rather complicated GraphQL query, which allows me to introduce some vocabulary. A GraphQL query starts with, perfect. In the top left corner, an operation. There are two main kinds of operations, queries and mutations. We can loosely map those to queries mapped to GET requests, GET HTTP requests, and mutations to HTTP POST requests. We will detail all the other kinds of tokens in this query when we will talk about the vulnerabilities they imply. There are two interesting metrics regarding GraphQL queries. The depth is the level of nesting, the deepest field in the query, and the width is the total number of fields in the query. We said graph model. Here is a representation of a dummy GraphQL API. And let's say, for instance, we have a type on the right-hand side exposing a stripe token field and a path in blue leading to this field. Well, since our data model is a graph, there may be several paths leading to this field. For instance, a shorter one here in red and a longer one in orange, effectively creating some kind of access control nightmare. I guess that's your turn.
So now we will talk about the escape magic and why is it hard to test production application. But it's a fundamental problem. It's not specific to GraphQL. Any application is hard to test dynamically. So first, only very few companies how they integrate automated dynamic security testing pipelines. This is becoming more frequent with SOC compliance and compliance in payment system and compliance in general. Secondly, most of security solutions use fuzzing algorithms. So sometimes fuzzing algorithms are really simple, but sometimes are really advanced. If you take, for example, ledgers and stuff, they will use a lot of fuzzing testing, really advanced. And anything that is coming to binary exploitation is about fuzzing, but API is quite different. And often security solutions do not pass the validation layer, and so they never test the business logic, whereas most of security vulnerabilities are present. So that's why we developed a unique algorithm that we call feedback-driven exploration that is specifically designed to learn about the application, about its business rules, and the way it actually organizes objects. This system was specifically designed to work on GraphQL, but we reached the state of the art in that field, and we are now battle testing it on different protocols such as REST or gRPC application. To explain it really simply, we will go to the next slide. So you can take a look on that part. You will see that you have way more coherent data than on the other one. So on the right side, you will find a query that is totally randomly generated. And on the other side, you will find something which looks like an UID, an email which is very likely to be gathered from the application. And you also have an injection in the password. So Escape is scanning in two different steps. There is the first step where we gather a lot of data from the application, trying to understand this business logic, and we will change a very few things after that to test about vulnerabilities. If some of you knows Nuclei out there with bug bounty testing, you can see Escape as like Nuclei on really, really strong steroids with this feedback-driven exploration algorithm. So, as Gautier just mentioned, GraphQL is a graph, and resources are all organized as a graph. So it's becoming very hard to automatize that with software because application can be very huge with federation and stuff. We today have algorithms that are capable of operating both deep and wide and actually testing all paths, all parameters, and all objects in a GraphQL schema. That was not an easy journey to manage this recursive behavior.
Yeah, so we build a complicated algorithm, we make it run on the internet with what we found. More than 40,000 alerts, which we will review one by one right now. No, just kidding. Here is what we found grouped by categories. In this big list, there are GraphQL-specific errors, vulnerabilities, and some kind of vulnerabilities that has existed ever since APIs existed. For instance, publicly available stack traces, unsafe routes, GraphQL injections. Let's take a look at this first three to begin with. Here is a GraphQL server which has its debug settings still on production, and it's about 12% of all GraphQL endpoints we tested. And why is it a vulnerability? Because some stack traces just dumps library versions. For instance, this server is using a deprecated library with a very critical, not high, CVE on it. The next one is unsafe route being public, which means, in fact, that the mutation, which can affect, edit data on a server, are missing some access control. Last but not least, we found many SQL injections. They are still there. One bash command injection, which means we can just run code on the remote machine. And 3 server-side request forgeries. We were able to intercept machine-to-machine communications to leak some API secrets. More on that later. Now let's jump into the GraphQL-specific vulnerabilities. We group them in 4 categories: API brute forcing, denial of service, API schema leak, and unsafe public operations. The first one, API brute forcing, leverages a feature, or 2 features actually, named batching and aliasing, which can, by design, group several GraphQL requests in a single HTTP exchange, making the whole exchange faster on the internet. Because some web application firewalls count requests at the HTTP level, it allows an attacker to run some kind of brute force attacks, to run, for instance, 3 or more login attempts in a single HTTP request, effectively bypassing rate limiting.
So here's a quick conclusion of the consequences you can have through brute forcing. So stolen user account, because you can actually brute force and say, okay, I will try 10,000 of PIN password tries in one request, and because I bypass the rate limit, and you can extract sensitive data using such techniques.
Yeah, and this feature, aliasing, when coupled with another feature named GraphQL file uploads, can lead to a modern version of zip bombs. We named it GraphQL bombs. For instance, let's consider uploading a single file of 1 megabyte, but if we reference it 1,000 times in a request, with a 1 megabyte HTTP exchange, we are able to create 1 gigabyte of work on the endpoint. So we can add GraphQL bombs to the list of consequences. This time's for you.
Okay, all right. For the second vulnerability, we'll talk about denial of services, and we will take fragments as examples. So fragments is another feature of GraphQL. You can see that as a function if regular programming languages. So I may ask you what could go wrong if you have a language that is recursive by design, if you implement a function in it. So let's get an example of that. So this is a very simple example. We are declaring a query which call a fragment X. We are declaring a fragment X which call fragment Y, and so on. So congratulations, you made your first infinite fragment recursion loop. So this is an updated stack trace. So most of JavaScript-based and Python-based engine don't want to actually cover these cases because it's handled by the language's safeguard on recursion, but still you get an interesting stack trace. Let's think about compiled languages, because this thing is in the GraphQL RFC. So compiled languages such as Golang and Rust do not support this at all. So if you use Rust here, my team and I made Rust more secure because we published multiple CVEs. So this is a different attack, but still on fragments. You can check on GitHub advisory if you want the detailed explanation. So we're only disclosing the ones that do not affect GraphQL RFCs and are related to the implementation itself, depending on the languages. So in that specific example, just to be quick, we nested a lot of fragments together, and we lead to memory overflow and took down any Rust server almost instantly. So as I said, we made a lot of contribution to JavaScript engine and Java engine, which is used by most Fortune 500. And so at Escape, we do run into a lot of 0 days, but we are always reaching GraphQL Foundation and maintainers first before disclosing. Consequences of denial of service could be an API availability for some time and a total API shutdown. So the third interesting vulnerability specific to GraphQL is schema leak. So GraphQL provides some introspection capabilities, but you can disable this feature to hide your schema. But with another GraphQL feature, field suggestion, you can rebuild the schema from scratch. So with file suggestion, any misspelled query will be corrected to something that actually exists in the schema, even if the introspection is disabled. So that is an example of schema we reconstructed through Clairvoyance. Clairvoyance is an open source package that you might be using already if you are doing bug bounties on GraphQL. We contributed a lot at Escape on this package. This is totally open source. So here is a practical example in that specific schema. On this side, you have the schema that we found through the introspection. And someone just thought it was interesting to hide update time in query because it wasn't protected. So we changed the password, and someone was not happy. Yep. So we highly discourage considering security through obfuscation because pen testers are always capable of restituting such information. So we can see the consequences of schema leak, access to unauthorized function that you previously hide, and easy compromission because if you have an update admin query, you just have a backdoor in your API.
We also found a shovel full of publicly available information in 2 big categories. PIIs, personally identifiable information, and tokens, API, machine-to-machine tokens. Among those, in the PII category, we found a lot of email and phone numbers, which in this case could be false positives, like support address emails, support phone numbers, sales phone numbers, etc. But that was never the case for passport numbers and bank account numbers, which are far more critical. On the other hand, we managed to dump a lot of machine-to-machine tokens, like Amazon Web Services tokens, Google Cloud Platform tokens, private RSA keys and certificates, and auth tokens to Adobe, Asana, GitHub, and even one ChatGPT token. All these GraphQL-specific vulnerabilities, these 4 categories, can be linked to the more common WASP top 10 vulnerability classification that Tobias showed a while ago. For instance, the DOS and complexity issues fall under the API 04 category. Access control fall under all the access control OWASP top 10 categories, 01, 02, and 05. And security misconfigurations and information disclosure fall into the API 07 category. To sum up what you could read in the report, we found more than 100,000 public GraphQL APIs on the internet through GitHub searches, Google searches, only OSINT. We narrowed this list down to 1,000, a bit more than 1,000, based on 2 criterions. They need to be publicly accessible without any kind of authentication. So that's the unauthenticated criterion, and have their introspection open, which means that we can get the whole schema from the API without needing to reverse engineer it with the suggestions, for instance. All the vulnerabilities you saw, some are GraphQL-specific, which can be the most devastating ones, but some are as old as the internet. And denial of services are possible quite easily by default, because GraphQL engines feature no hard limits on query depth and query width, which can lead, in the case of GraphQL gateway, to a single point of failure. Because you're able to down the gateway, you're able to down all the infrastructure. You can scan the QR code to download the whole paper. You will get more information on the 46,000 alerts we did not detail, which makes a lot of pages. And
all right. So let's see how we are trying to make the web app ecosystem more secure, so not specifically GraphQL. And that is a few surprises we talked about at the start of the talk. First, we can tell you about GraphQL Armor. GraphQL Armor is a completely free and open source package that is a one-line installation for JavaScript-based engines. You can remediate to a dozen of GraphQL-specific vulnerabilities, such as alias limit, character limits, depth limit, and field suggestion, and so on. So check that out if you are like a GraphQL developer or trying to improve in bug bounty. So just type GraphQL Armor, and if you want to make a contribution, we always accept contribution. So as I said, we recently extended our algorithm to REST application. So we did the exact same report on REST application. So we published a website called apirank.dev. We ranked every APIs on different criteria, but so we scanned again the internet, trying to find unauthenticated and public API. You have, for example, Spotify, SoundCloud, etc. So we had in mind that if you come to choose your next payment solution, you could choose between Stripe, checkout.com, and so on. So we ranked every API using different criteria such as security, so compliance with OWASP top 10, performances, so pure speed, reliability, and design, is your application commented, and so on. And we still found an interesting token in all these APIs, GWT, emails, and because it's really interesting because it's super recent, we found a few OpenAI API keys. For the numbers, we scanned over 6,000 API. We found a bit less of vulnerabilities this time because we didn't add the GraphQL-specific vulnerabilities. And if we have some DevOps writer, you also have the technical specifications.
And last but not least, we are launching a free, completely free API Security Academy, which can be accessed through this link. It's a platform to learn about API security using both approaches. First, a red team approach, so you get to learn about a vulnerability. You get to learn how to exploit it. And then you take the blue team approach. You have to patch it and effectively prove that the vulnerability is patched. What's interesting about this site is that it runs entirely in your browser. You got a full Node.js development environment working in your browser through web containers, so it can work completely offline. Thank you for your... no? Not yet? Ah, yeah. Here is the details of what a lesson looks like. It's a complete integrated developer environment with a file system, the explanation of what the vulnerability is, usually small. Yeah, what's wrong? Yeah, small servers with one specific vulnerability. Yeah, so take a look. It's open source, it's on GitHub, and it's currently on beta. Please file bug reports.
So that's all for today. We're still hiring if you are interested in cybersecurity, software engineering, or full stack web development. We are based in Paris. So if you want to visit France, that could be a good opportunity. And there is our handles if you want to add on LinkedIn, send a mail, and maybe meet again at some conferences. Thanks.
Thanks. Thanks, guys, for traveling to be with us here today. That was great. Does anybody have any questions? Hand in the back, coming back. Keep it up. Where was the hand? Yes.
Thank you, sir. Hi, guys. Thanks. So first of all, your research is based on the APIs with which all have introspection open, right?
Yes.
So would you consider disabling introspection a must in this case as a step one to protect the API? And how much would disabled introspection make your work more time consuming?
So as I said with schema leaks, even if the introspection is closed, we can reconstruct the application. So I won't go too deep in this part, but so we contributed and made Clairvoyance open source. Most of the code is written by escape guys, but you could always, with some complex NLP algorithm, fall back to rebuilding a complete specification, even if the field suggestion is closed. There is some heuristics available out there, but that's another stuff.
So basically, you consider disabling introspection a security for obscurity, right?
Yeah,
okay.
It doesn't
Thanks.
work. Security by obscurity is not recommended at all. You shouldn't consider it.
Also, if your API has a front end, the front end will contain some GraphQL queries that you can already take as a base of knowledge to create more complicated queries.
Any other questions? Looking up at the balcony. No? Okay. Are you here for the rest of the day
Yes.
and hopefully the evening? Thank you so much to Gautier and Swan.